Hi. So far we've looked at inputs and outputs, and the inputs we've looked at have been very simple, straightforward push switches. But there are many other devices that also use very simple digital inputs and outputs. So they provide ones and zeros as inputs to the Arduino. And what we're going to look at today is we're going to use a proximity sensor. Now, a proximity sensor has, let me bring it over onto the overhead. The proximity sensor has two LEDs. Well, technically, this is an LED and this is a photodiode. It's a receiver. This will emit infrared light, and if there is something within a certain distance, a reflection will be made, and the reflection will be picked up by this photodiode. There's a little bit of circuitry on board that will actually then turn this pin here on or off. In fact, if you look at yours, the three pins are actually labeled. Focus. Nope, doesn't want to focus. But if you look at yours, then we have an output pin, a ground pin, and a VCC or a positive pin. This one doesn't need any pull up or pull down resistors because they're actually built in on board. But what you might find useful is a small crosshead screwdriver, because this is a variable resistor. Don't turn it too hard because you can break it. But if you can rotate this blue device, you actually adjust the sensitivity and the trigger point of the actual detector. So let's jump into fritzing, and then we can have a look about how we might wire up this device. So here is our sensor, and I've got my breadboard, my Arduino, and two LEDs, one green one, one red one, and two resistors, both of which are 220 ohms. So red, red, black, black. Standard protect an LED resistor. So what I'm going to do is I'm first of all going to just plug this. Actually, I'll plug it in a bit higher. I'm going to plug it into into columns 2, 3, and 4. Now we need to connect this up, so we're going to connect ground to ground. And I'm just going to tidy the wires up so it's a bit neater for you. And I'm going to make that a black wire. VCC is going to go into 5 volts. Let's make that a red wire. And then we're going to connect our output to one of our input pins. I'm going to put it on pin 13 for no other reason than pin 13 is there. Trying to make it as neat on here as I can. And let's use an orange wire for that. So we're going output to pin 13. So we'll use pin 13 as our digital input. Now we have our two LEDs. Remember the LED? The big pole inside is negative. And we have our resistors. So what I'm going to do, I'm going to put my resistors. Let's put one here, one here, so that we've got this common central bit, and we'll connect that to ground. Let's grab the right bit. And I'll make that black so it's consistent with everything else. And then what I'm going to do is I'm going to take my green LED, and I'll put that in there. And I'll put my red LED in here, making sure that I'm putting the big connection to my resistor. And then the final thing is I'm going to connect both of these pins up to the Uno. And I think I'm going to put the red one on pin 2. And I'm going to put the green one on pin 3. And I'm just going to tidy these up a touch because that's going to irritate me otherwise. So we have a sensor wire coming in on pin 13. We have positive fed to the VCC line, negative fed to the ground line, negative coming to between our two resistors, the other side of our resistors coming into the negative of our LEDs, and then the positives of our LEDs connected to pins 2 and 3. So once again, if we look at the actual board, we should be able to connect this up. So I'm going to put my sensor in over here, and I'm going to take my resistors and make a pair, something like that. Could be neater, but it's about right. I'm going to take my red LED, making sure I put my big pole, the short leg, the big inside. Line that one up correctly. And do the same for the green one. So positives on the inside. And now all I need are my wires. So ground to the middle pin on the sensor gives me ground. I'm actually probably going to put this a bit further this way, and I'll plug it in behind so that it's easier for me to get to the variable resistor. 5 volts. It's going to go next to it on the VCC line. And as soon as I did that, some lights on my actual sensor switched on. Then it's orange to pin 13, yellow pin 2 to my red LED, and green on pin 3 to my green LED. So spend some time, get that set up like that, and then we'll be back to actually program this. Okay, so you've got your circuit built. Before you can actually use it, however, you actually need to tune and set up the proximity sensor. So I've moved the camera so that you can see the proximity sensor. You'll notice that there are 2 LEDs, one on the right, one on the left. The one on the right is the power LED, and that will always be on. The one on the left is the detecting LED. You may have at the moment 2 green LEDs on, or you may not. If we turn the dial to the right, that changes what's called the bias in here, and the green light comes on. Whatever happens now, doesn't matter where you put your hand. I'm putting my hand near the sensor. It's always going to detect an object being there. If I turn the potentiometer, the variable resistor, all the way the other way, anti-clockwise, the light goes out, but now it never detects anything. What you need to do is adjust this slightly, and it's on a per device setting, so that when you bring your thumb or some other object close to the lights, to the LEDs, that detection LED switches on or switches off. You might find it somewhat easier to bend these LEDs away from the board slightly. If you do it very gently, but try and set it up so that your thumb coming into the beam, and it's about 5 centimeters away, triggers the light coming on.